So yes, so IEEE, world's largest professional technical society, basically most of the major standards that are out there, particularly in terms of Ethernet and Wi-Fi, they're developed by IEEE standards committees. And IEEE publishes something like 2/3 of the world's literature on electronics and electrical and computer technology. The IEEE Toronto section, we've been around for over 100 and almost 120 years. There's approximately 4,000 members in the GTA. Most of, if not all, the IEEE sort of technical societies are represented in the GTA. So there's lots of activity, not only in our chapter, but in many other chapters. And just some web links are shown here to link directly to computer events, past computer events. So myself, my name's Dennis Sessick. I work as a technical training engineer for a semiconductor company called Microchip Technology. My background is more in microcontroller-based embedded systems, wireless protocols, IoT applications, again, relating to devices, like really small constrained devices. Yunus is our vice chair. He works in near precision monitoring, and his technical focus, as you can understand from his introduction, is on IT infrastructure, both on premises and cloud. And Shahram Nagari is our secretary. He's also joining us this evening. He's a technical manager at TechnoExpert, and his background is in technical focus in power systems, smart grid, and also IoT applications. So basically, the computer is the largest technical society within IEEE. The main website is computer.org. Lots of chapters, lots of standards groups. And if you are really interested in getting involved at the standards level, running conferences, there's a lot of opportunity to interact with your colleagues. So as Yunus mentioned, we're really focusing, I guess, this year on cloud security. And my understanding is we are planning another data science presentation later in the second calendar quarter of this year. And like Yunus said, I mean, security is a big sort of application focus for topics for events for this year. Tech Bytes, this is a relatively new initiative. If you're interested in sharing some practical knowledge by writing articles, we are looking for authors. And if you have something, if you want to share, write some articles that are sort of practical information for young engineers, we have a page on our IEEE Toronto website that's dedicated to publishing short articles. So you can just reach us at events.toronto@ieee.org if you have an interest in contributing an article. So call to action, IEEE Toronto website is just very simple to remember, ieeetoronto.ca. Joining the Computer Society is the best way to keep up with what Yunus and myself and Shahram are up to in terms of events for C16 in Toronto. And again, we're on all the social media channels right now, and these links are on the homepage for IEEE Toronto. So again, thanks for this introduction, and I'll turn it over to Zia from WinMagic.
Thank you, Dennis. Let me start sharing the screen. Okay, yeah, I will now start. Okay, thank you, Dennis and Yunus, for setting this this presentation up, this session up. I appreciate the invite and I appreciate the opportunity to come and talk to everyone. So my name is Zia, and today I'll be talking about derivative security using artificial intelligence. So what does that mean? What does derivative security mean, and why artificial intelligence? The problem is with the volume of data that we are collecting. So organizations are collecting huge volumes of data. Often it's structured, but there's unstructured data that is being collected as well. And this unstructured data is difficult to curate, it's difficult to process, it's difficult to find things out, it's difficult to locate where all of this data is floating within an organization. This results a big problem. There are a number of regulations which are being brought about that ask organizations to control the data that they are collecting and managing within the organization. So how do companies do this. So this is what my topic is. How do we manage data security using artificial intelligence? A little bit about myself. So I've
Zia,
been, yeah,
Zia,
yes.
yeah, I have a question.
Mm-hmm.
What can you give us some examples? What do you mean by unstructured data? Give me
Yeah,
some examples.
yeah. Um, so I'll come to that in a few slides, but
Okay.
the idea is that unstructured data is emails, audio clips, video clips, data that does not have a defined structure to it. And I'll give examples of that in a few slides. But yeah, that's a good question.
Okay. Thanks.
Yeah. And a little bit about myself. So I have been working for 20 years, over 20 years. I have considerable experience in the design development of information systems, enterprise applications, data engineering platforms, distributed systems. I particularly like incorporating machine learning techniques and deep learning techniques into software applications to so make them a little more smarter than they could be if we wrote the applications using rules. I got my PhD from the University of Toronto. Since this is an IEEE session and we're talking about IEEE activities and standards, so I've also been a contributor to IEEE standards. So there's a standard called IEEE 802.17. I was a contributor to that, the formation of that standard. It was accepted long time back. So that was there. In addition to this, we're talking about cloud and we're talking about data. Some are contributed to the cloud security alliance as well. So in addition to my professional experiences, I participate in a number of research related initiatives, both at the academic front as well as the industry front. Okay. So yeah, so let's start. The background is, so organizations are increasingly expected to adhere to data governance requirements. The data governance requirements can be fairly stringent, and it varies by industry to industry. So, for example, what are these data governance standards that we find ourselves? If you're looking at the healthcare industry, then there's something called HIPAA. HIPAA is a regulation that controls the amount of what you can do with patient data. So how do you manage patient data? Who should it be shared with? What are the security provisions that need to be considered around collecting patient data and sharing it with other individuals, both for research purposes and for treatment purposes? So a number of regulations around enterprise data. If we are talking about the financial services industry, particularly the payment services industry, then there's a regulation called PCI DSS. PCI DSS stands for Payment Card Industry Data Security Standard. Over here, this is a number of requirements that organizations have to go through in order to certify themselves as being PCI DSS compliant. It means that we have to follow fairly rigorous standards around security controls, both from a process standpoint and from a data standpoint and from a system standpoint. So the number of regulations that need to be followed, which is fairly tricky for an organization to attain. If we are talking about other standards in the financial services industry, financial institutions need to follow something like GLBA, which is when banks are collecting data, how are they managing that? How are they protecting data? So there are certain controls which are built as part of the GLBA that organizations have to satisfy. Sarbanes-Oxley Act came about, I think, 15 years ago or thereabouts, when there were a number of scandals that happened in the late noughts, 2007, 2008. And one side consequence of those was the formation of the Sarbanes-Oxley Act, SOX. And within that, there are clauses that control how data should be managed. So how data is being encrypted, how data is being protected, how data is being stored. It's a number of clauses around data security. Again, continuing on with payment services, PSD2 is a European Union directive. Other countries are adopting it or variants of that just to make sure they are compliant or they can do business within the European Union. But PSD2 is primarily a EU directive. And that is how is data protected during end-to-end payments. And so we can continue on and on. There are many, many regulations around protecting data in an organization. GDPR is one that that is being talked about quite a bit. GDPR stands for General Data Protection Regulation. It's a set of rules designed to keep EU citizens protected and to give them more control over their personal data. So this applies to European Union citizens and organizations that are based in the European Union. When I say based, I don't mean headquartered, just headquartered, but are organizations that are operating them. So it could be a US company that has operations in the European Union. So they need to comply with GDPR as well. And the idea is citizens should have control over their personal data. So it's not once they give uh, their personal data to an organization and that organization can do whatever they want with it. No, the individuals still control their data. It's still their data. They've given an organization permission to use it for a certain reasons, not beyond that. Now, GDPR is becoming a big problem for organizations, and it's very difficult for organizations to comply with that. And I'll talk about one facet of it. I won't talk about GDPR. This is, it's a very big topic. It's difficult to cover in a single session. But GDPR is one particular facet of GDPR is the right to be forgotten. I have that in. Let me just get a pointer here. The right to be forgotten. What does this mean? This means that if I volunteer my personal data to an organization, and that organization, that could be in the form of pictures, it could be video, clips that I've uploaded, it could be some other personal information that I've uploaded, that is to be used by the organization for the purpose for which it was collected. But later on, I may decide not to, for that organization to use it for whatever purpose I gave it to them. And also, I should have the right for my data not to be presented to the rest of the world. So at some point in time, I may decide that my data should not be presented to the rest of the world. Or even if data about me has been collected by the organization, and I don't want that data to be shared with the rest of the world, I can raise this point to the organization. Hey, you know what? This data that you have collected, legally collected, either from me or from some other source, should not be used for whatever purpose you're using it anymore. So just to give a few practical examples, let's say I have a Facebook account. And Facebook, while it's a US organization, it has operations in the European Union. So GDPR applies to Facebook. And I've uploaded pictures of mine and I've uploaded video clips of mine, and they are on my Facebook page. People who are friends of mine on Facebook can view all of them. Some of those clips I may have made them public, so people from the broader world can view my pictures and my videos that I have on Facebook. I should have at some point the right to delete that data, so it is no longer visible to people. So that's one thing that I should have the right. So GDPR gives me the right. It empowers me to ask Facebook to delete my information that they've collected from me. Another example is of, for example, Google. Google again is a US organization, but it has operations in the European Union, so GDPR applies to that as well. Let's say there's something that I did, I don't know, it's a long time back, and I don't want that to come on my Google search. If someone searches for my name, I don't want that to be appearing. It's something that was done 10, 15, 20 years back. It's probably hurting the chances of me or you or anyone getting employment. So that individual under GDPR has the permission and has the right to ask Google to delete their data from the results that come up on Google. So if someone, let's say, was arrested for some kind of minor offense 20 years ago, and now 20 years later they are trying to find employment, and whenever someone searches their name and that comes up, well, it's unfortunate that something that happened 20 years ago is affecting their employment chances right now. So that individual would have the right to make a request to Google saying, can you please not share this information in your search results? And Google would have to respect that under GDPR. So these are certain clauses that organizations have to adhere to when they hope to do operations in the European Union. Okay, so there was a question on, so Dennis asked, what is unstructured data and how does it differ, for example, structured data? So data can take different shapes and forms. Typically we classify data as structured data or unstructured data when we're talking about databases. A structured data is some data that has a structure to it. So for example, a financial transaction has a structure to it. When does this transaction happen? Where was it originating from? Where did it go to? What was the amount of the transaction? What type of transaction that was? So there's a defined structure to this financial transaction, to this payment transaction that happened. There may be other transactions that we can think about. Again, these have defined structures. It could be some kind of sensor that is constantly recording data. That sensor has, when it's writing a record to a database, it has a defined structure to it. At the time the observation was made, what type of observation it was, what the value of that observation was. There are defined values in that record. So that is all structured data because there's a very defined structure to that data. On the other side, you have unstructured data. Unstructured data is data where there is no defined structure to it. So for example, an audio file. An audio file is, essentially just binary data. There are no fields in that audio file. There is some metadata, which is a separate thing, but the actual audio file is just a series of binary data points that is, doesn't have any sense to it, any structure to it. Same goes for pictures. So pictures, audio files, video files, all of these are classified as unstructured data. Data, documents, same thing. Two documents would not match. Like in structured data, every record matches to the other record. The values, the field values would be different, but they all contain the same structure. Whereas if you have a collection of pictures, well, it could vary. They could be different sizes, they could be different colors, they could be different textures, they could be different, you know, I don't know, resolutions. So there's a lot of variation between pictures. So there's no defined structure to a collection of pictures or a collection of videos. So that's why we called it that, unstructured data. And in between, there's something called semi-structured data. That is, somewhere in between structured data and unstructured data. Emails are often given examples as semi-structured data. Why emails? Because when you send an email, there are certain defined fields which are present. Who does this email come from? Who is it going to? Are there any people in the CC field? What time this email was sent? What time this email was received? So there are a number of defined fields that exist across all emails, but the body of the email can vary. So that's why we call it semi-structured, because there's some structure to emails which are exchanged between individuals, whereas the body varies. So the body is the unstructured part. So that's why we call it semi-structured. So between structured, semi-structured, and unstructured, we are covering the complete spectrum of data. Okay. Now coming back to the problem of data security and how to manage data in an organization. So let's say if an organization, I've uploaded my data to any organization to Facebook. Now Facebook has a collection of my pictures and my videos and all of the posts that I've made over the last few years. That's all great. However, it's quite possible that within Facebook, the data gets scattered throughout the organization. So for example, in this picture, I represent this as source data. This is where the central repository of all the data is present. This data could be copied throughout the organization legitimately. For example, a data scientist may download a copy of that data to do some analytical modeling, some kind of machine learning exercise. Some of these files may be emailed to someone else saying that, hey, can you take a look at this? How do we process this? And there may be some training data that has been created from the source data, and that's another scattering of the data that has happened. So what happens within a few months and years, the data that was first in a single location is now scattered throughout the organization. And if that individual, if for example myself or some other individual comes back to Facebook and say, hey, can you now under GDPR make sure that my data is no longer being used for whatever reason that I previously gave you permission to use. The problem is the organization, Facebook in this case, is going to struggle to find all copies of that data that were created in the many years that they had it and go and delete it, because they don't know how far the data has gone. They don't know which databases. If it's stored just in databases, that's fine. It's quite possible we can go through that cleaning exercise. However, if it's been emailed, if it's been downloaded, how do you go about looking at different file systems, different laptops and PCs and email accounts to find wherever the data is and go and delete it? Yeah. So this is somewhat of a problem, and this needs to be solved. Okay. So this is where the idea of derivative data security comes. So when we say derivative data security, what we mean by this is to find out all of the derivative of an original copy. So we have an original data source, and we are trying to find all the derivative copies of that original data source and make sure that we are able to locate them and detect them and delete them later on if we need to do so. So that's why I'm calling it derivative data security, that we want to maintain data security, but we want to maintain data security of derivatives. Derivatives are copies from an original data source. So derivative data is data that is derived from some primary data source, particularly unstructured. So let's say it's a picture that has been uploaded. That picture, a copy of that picture is now being made, and that copy is a derivative of that original picture. So example, an image that has been emailed to someone. So someone downloaded a copy, a picture, legitimate purposes. Someone downloaded an image from the central database, and that image has now been emailed to someone. Well, now that is a derivative of an original copy, and we need to keep track of that, or at least we need to determine everywhere that those copies exist. A text document that has been emailed or shared within an organization, or even a paragraph that has been copied from a text document, that is also a derivative. It's a partial derivative, but it's still a derivative. So that's another thing that needs to be determined and detected. So derivatives can be complete copies, or they could be partial copies. Like a document could be copied in its entirely, or an image could be copied in its entirely, or for that matter, you could crop a portion of an image, or you could copy a paragraph in a document. So these are going to be partial derivatives of a document. Okay. So how do we solve this problem? How do we determine where the derivatives are within an organization? And how do we use machine learning techniques and deep learning techniques for this purpose? So there could be questions that we want to ask. Are two images similar to each other? What that means is, if I have a source image and I went and made a copy of that, can I determine if two images are similar to each other or not? And I don't mean identical, I mean similar. If based on a ranking, based on a score, I can determine if a second image is similar to a first image. If the score is very high, that means it's mostly similar. If it's very low, then I know that it's not that similar. So this is one way of finding derivatives. And machine learning and deep learning techniques work fairly well. Okay, so I'm going to do an experiment. I'm going to do two experiments over here. One experiment is on documents, to show how two documents can be used, how similar documents could be found from each other. And I have three documents over here in this example that I'll be showing. I have document 1, 2, and 3. And these documents, I generated them from an AI bot. So there's the link below, you see an AI bot that is present over there. And you give it a starting text, and it would go in and create a complete document or a paragraph for you. So what I did was I asked that AI bot to create three documents for me. Actually, I asked it to create one document for me, and then I created copies of that. So derivatives of that original document. The original document is doc1, and doc2 and doc3 are derivatives of that original document. Okay. So let me show you those documents as well. Just give me a second.
Yeah, would you like to answer some of the questions? We have got one question here, or would you like to proceed
Yes,
further?
please. Can you please read them out? Because I can't see them on my screen right now.
Sure, let me read it. The question is, in case of an email, isn't the receiver the new owner of the copy? It's a...
Yes, in case of an email, if someone receives an email, so there are two versions of that email. So the sender has a version and the receiver has a version. So it is one version of truth, so that is fine. But what if someone copies a portion of that email and sends it out further? So that would be a derivative from the original email that has been sent out.
Can I expand on my question,
Yeah,
Zia?
yeah,
Well,
please.
for instance, let's say that I received an email from a friend, and the email contains a picture of somebody who wants to be forgotten now. But I use the picture for some research or whatever. And now the person wants to delete everything which is relevant to her or to him. But my copy is now my copy. How can you actually solve this from a legal point of view? Is that my actually right to keep the copy, or the person's right to have it deleted from my records and my files? Let's say that, for instance, put it another way.
Yeah.
I am Toronto police,
Mm-hmm.
and I have records of all the criminal activities, even after 20 years or after 100 years. And now somebody wants to delete all the information and wants to actually exact the right of being forgotten. So what happens here?
That's a good question. So a lot of these are organization policies that govern what happens. So these cases are usually covered in organization policy. It's organizations may say that any copy that is created is needs to be carefully maintained and managed, and needs to be deleted. So that's an organization policy. Or organizations would say that if legitimate copies are made for the purpose of work, then that is fine. My experience has been an organization says that if you create a copy, that copy still comes under the organization policy. So if it needs to be deleted, then it needs to be deleted. I'm not sure if I answered your question or not, but I just wanted to make sure. Yeah, it's I would say that varies significantly from organization to organization. Some organizations are very stringent about it. This is our confidential information. If you make a copy of this, you have to be very careful, and you can only use it for the purpose that we are granting you permission to use it. Source code, for example, that is again IP that organizations take very seriously, and they make sure that you respect the reasons under which that source code has been given to you.
I think I think one to expand is the point that has been made is that if your organization has a policy of keeping the copy even, but if your organization sends that email out somebody who is outside the organization, so can your organization enforce its policy to the person who that email is sent to, who is outside your organization? Because that person gonna keep that email for as long as you want.
True. Okay, so just I wanted to show you the data that I have. So these are 3 text files that I have. I mentioned doc1. So this is doc1. This is the file that was generated by the AI bot. And then I have doc2 as well. So this is, it just contains the second paragraph. It doesn't contain the full document. So this is a derivative of the first document. And then I have doc3.txt. And this is just one single line, the first line. It doesn't contain anything else. So you can see that I have an original document that is 3 paragraphs long. Then I have a derivative document that is just 1 paragraph long. And I have another derivative document from the first document that is a single line long. And now what I'm going to do is try to find similarity between all of these documents using machine learning. So how does machine learning work over here for this purpose? There are 5 steps which are used. The steps are as follows, where the first is I determine the corpus of my documents. So all of the 3 documents what I have a corpus of, I create a corpus. A corpus is basically the dictionary, all the words which are present in these documents. I would then convert the sentences in our collection of documents into tokens. So this is a method that is being used because what happens is machine learning algorithms, they take numbers in and they spit out numbers. So I can't give it documents, I can't give it words. So I need to somehow convert it into numbers. I need to convert it into a vector. So what I'm going to do is I'm going to do what we call tokenization of the sentences, where I'm converting the sentences into vectors. And another step is and then create a dictionary of word frequency. And I'll give examples of this in a few slides. Once I've done that, in order to improve things, I'll use an approach called TF-IDF for all of the words and the values. This is usually done in order to de-emphasize and re-emphasize certain words based on the frequency at which they are present in sentences. Because more common words like the and they're not that relevant. So we want to de-emphasize them, and other words which are more less frequent, that are usually a little more important, we want to overemphasize those words. And finally, as I mentioned, all of these sentences and words, they are converted as vectors that are going to be used in the database and stored in the database. And the database that I'm using is MongoDB. Okay. Yeah, so what is TF-IDF? TF-IDF is a technique that emphasizes or de-emphasizes certain words based on the frequency at which they are present. So for example, we have 3 sentences over here. I like to play football. Did you go outside to play tennis? And John and I played tennis. So some words like to are present in multiple places. And other words like and may also be very prevalent and present. The way it works is, first we tokenize the document. So we take those 3 sentences, I like to play football, and we have these, and we say that, okay, these are the sentences which are present in my document. So I have 3 sentences, these are the sentences that I have. For each of one of these sentences, what we do is we, for each one of the word in that corpus, what we do is we calculate the frequency that it is present. So term frequency is the frequency of the word in the document and over the total number of words in that document. So right now, we're just first step is calculating the frequency of each one of these words. So play appeared 3 times in that corpus, in that 3 documents that we had, the 3 sentences that we had. Tennis came twice, to came twice, I came twice, football once, did you once. So first we find the frequency that these words are present in that corpus. And then what we do is we calculate the inverse document frequency, which is we take the frequency and we see how many documents contain that word that we found. So play, we saw that the frequency was 3 and it was present in all 3 documents. So this gives an IDF value of 1. Tennis appeared twice and it was present in 2 documents. Sorry, tennis appeared 3 times and it appeared in 2 documents. So that's why we get a value of 1.5. And we can go down this entire list to calculate the IDF values. Okay, finally, what we did is, in order to get the TF-IDF value, we take the TF value, the term frequency value, and we multiply it with the IDF value that we calculated in the previous step. And if we do this for all of the words, so we take the TF value and we multiply it with the IDF value, we get something like 0.20. If we do it for tennis, we'll get something like 0. 2 will get 0.30. I will get 0.30. Football will get 0.6. If we continue through this entire exercise, we get something like this value. So for each document, each sentence, we are coming up with the respective values. Now what happens is this looks remarkable like a vector. So what we've done is we've converted sentences and words into a vector. So this is one vector, this is another vector, and this is another vector. Okay. Now that we have vectors of 3 sentences, we can try to find how similar they are by doing something called similarity analysis or cosine similarity. So what is a vector? A vector is essentially, a single line over here that and the length of the line and the direction represents the vector over here. So if we have 2 vectors, for example, A and B, if they are on top of each other, meaning they're in the same direction, if they're in the same direction, maybe the magnitude may be different, but they're in the same direction, that means they are identical to each other. are similar to each other, very similar to each other, and we'll get a value of cosine value of 1. If there are slight differences between two vectors, then we won't get a 1, but we'll get a fairly high value, a cosine value of, for example, 0.86. However, if two vectors are not similar to each other at all, and for example, they are in the opposite direction, so we'll get a cosine value of -1, which signifies that these documents are not alike at all. So the cosine value can range between 1 to -1, and the value is going to indicate how similar two documents are. And by the way, these documents have been converted into vectors, and then we do cosine similarity on the vectors to see how similar they're going to be to each other. Okay, so let me show this. Let me show how all of this works. So I have a demo that I'll be showing. This is, I have one Python file. What it's doing is I'm running it on Ubuntu. So what it does is it goes through all of those 3 documents that I showed you, doc1, doc2, and doc3, and converts them into vectors using the 5 steps that I mentioned. And the values are stored in the Mongo database that I have running on a Docker container. And then I have another agent application. What it does is it can periodically ping this database and try to find the cosine similarity between all of those documents. So it takes each document and it compares it against all of the other documents that I have and see how similar they are to get an indication whether are these derivatives of an original document or not. So let me just bring all of this out. Okay. And I'll show you the code as well. Before I run it, it's always nice to see the code because we are all engineers over here. So I have 2 applications. I have agent.py and similar.py. The agent.py, what it does is it locates all of the documents, and for each of the document, it creates a vector and stores it in the database. So I'll walk you through some of the code that I have right now. So I have a few helper functions at the top, at the beginning over here. And this is where the main thing happens. So this function, this is what does text vectorization. So what I'll do is I'll get a folder that I need to scan. And what in that folder, I'll go through that folder and I'll locate all of the files which are present in that folder. And for each one of them, I'll use a toolkit called NLTK, Natural Language Toolkit. This is a machine learning library that is available. And I'll create a call. I'll use that, and for each one of those sentences, I'll use that sentence to create a corpus. A corpus, like I mentioned, is all of the words which are present in that collection of documents that I have. Okay. I'm doing some cleanup of the corpus over here, so getting rid of certain tags and end of files, things like that, commas, some special characters. And once I have that, then at this step is where I calculate the word frequency, just using the formula that I mentioned. At this point, I calculate the inverse IDF value, inverse distribution frequency. Over here, I calculate the term frequency. And in this step, I calculate the TF-IDF value for each word, each document in that corpus that I have. So these are the steps that I did, that I presented in the slides. It's fairly simple mathematics to do and go through all of them because a lot of these things are done using the framework that we have already. So once I have the TF-IDF values, I can print that out and I can show it to you, which I will in a few minutes. And you can see that, yes, indeed, this looks like a vector that is going to be used. Okay, so that was the main routine. That was the main function that does all of this. Or rather, that was the primary function that does the text vectorization. This is the main function. So when I run this code, this is what happens. It creates a connection to a Mongo database I have running in the background on Docker container. And I then go through the folder that I get as a parameter. And then in that folder, what I do is I get a list of all of the files which are present. And then I make a list of files which are present in that folder, and I have that printed out over here. Okay. On the similarity side, this is where I compare two vectors together to see how similar those documents, and the vectors are representing the documents. So what I'll do is I'll connect to the database, and then from the database, I will get a list of all of the vectors which are stored over there, which are present over there. And I'll go through them one by one. So I pick one vector and I compare all of the other vectors with that vector and see how similar they are. And if I find something that is beyond a certain threshold, like I use a threshold of 0.5 over here. So if I say that, okay, you know what, these two documents are remarkably similar to each other, then I'll just print out a message that this document and this document are fairly similar to each other. You may wish to check this in greater detail to see if someone has made a copy, either legitimate or illegitimate, doesn't really matter, but there is a copy that this program has located that exists out in the enterprise. So this is my second file for text classification. Let me run this code now. Okay. So these are the files that I have. So I'm going to run the first application, the first Python program. This is -f means this is the location that the files are present in. So I'm giving this as a command line parameter. And if I run this, so the code ran pretty quickly because I don't have a lot of files. If I had a lot of files, it would take a little longer. But this is what it printed. So I get some information about the Mongo database to make sure that indeed I connected correctly. This is the input folder that I passed in as a parameter. It found these files. So these are all the files which are present in that folder. So that was good. But I'm just interested in the text files for right now. I'm ignoring the image files. This code does not go through the images. It just goes through the text documents. So for the text documents, it printed out all of the text documents that it found, again for debug purposes. So this was the first document that I mentioned. This is a second document, and so this is a second document, I believe, and this was the third document, something like that. So it printed out all of the three documents. It then creates a corpus over here. This is where the vectors are created for each one of those three documents. So this, or for the sentences in the document. So not the document itself, because I want to, my granularity, it is at a sentence level. So I'm not doing this exercise at a document level because, like I mentioned, people could be extracting paragraphs or sentences within documents. So what I'm doing is my granularity is at a sentence level. I don't want to go below that, and I don't want to go above that. I don't want to do it at a paragraph level. So there were 9 sentences that it found. And for each one of those sentences, it created a text vector. And you can see the text vector present over here. So there should be 9 of these. And all of this data has now been sent to the Mongo database, and it's now present over there. I can show that to you as well. So the data that you see printed by the file, it's now present in the Mongo database, present over here. So these are, a Mongo database is a database. In case people are not acquainted with Mongo databases, there are 2 types of databases: the normal structured database, relational database, RDBMS, that's usually used for structured data. And then you have NoSQL databases, which are used for unstructured data. So in this, I have some unstructured text. So I've stored all of that information in a Mongo database. So if you just run this query, it'll show you all of the records which have been stored by that agent application that made a connection and uploaded all of this data. Okay. Now, let's say I have this. Let's say I have this done. So now my database has all of the values present. I need to find what are the documents which are similar to each other. So I'm going to run the similarity code. So I'll run the similarity code. And what this did is it did fairly simple. It picked the source document and it went through all of the other documents, all the other vectors, to see which ones are most similar. And whenever it found a match, it just mentioned that to all of us. So there are 9 sentences which it found, and what it's done is it's compared the sentences against each other and is trying to highlight if there is a similarity or not. So for example, over here it's saying that out of the 9 sentences that it found, sentence 4 and 0, they are completely identical. They have a value of 1, so they're completely identical. And sentence 7 and 3 are also completely identical. And there are 2 other sentences which are sort of similar to each other. So 5 and 1 are sort of similar, and 6 and 2 are sort of similar. They are the other matches. I did not print anything out for them because I remember I have a threshold of 0.5 over here. So if I reduce this threshold, if I make it to like 0.2, then I will get more matches. If I make it more strict, if I say 0.8 or so, then I'll get less matches. So I can change this threshold. But you can see that this is how it found matches between sentences that are similar across many different documents. And this is text classification, text vectorization, finding similarity using text vectorization techniques. Okay. So that is one type of document that we could find. I'll briefly pause in case there are any questions on this that I can address, and then I'll come to the next type of documents that I want to show, which is images. So can we do the same thing for images or not? Okay, I have a question. So if you have a document, just a set of random words that are the same corpus and frequency, would they consider similar by this algorithm? Yeah, that's a very good question. So if I have a random collection of words that is similar to the words which is present in a document that is a sensible document, so there is a defined language and sentences and grammar, would they be similar? The answer is no, they would not be similar, because I'm comparing it at a sentence level. If 2 sentences are not going to be matching, so even the words in the document be the same, but the sentences are not going to match, in which case that is not going to be a correct match. Yeah, because my comparisons are at a sentence level. I reduce every sentence into a vector, and I'm comparing sentences. And when I say sentences, then those words should be matching. But you are right that if the words in a sentences, if 2 sentences have the same words, would that result in an identical vector or not? My guess is yes, that's right. It would result in an identical vector, because we don't look at the sequence of words. That is being ignored right now. There are other machine learning and deep learning techniques that focus on the sequence of words, but this approach that I use does not focus on that. Yes, the meaning and syntax are ignored. That is correct. We don't look at semantic meaning right now. There are, again, deep learning techniques where you could focus on semantic meaning as well. So this is a very good question. Let's say if someone has changed the words so that the meaning is still the same, but the words are different. And you want to do, like, example, a plagiarism check, that despite the words being different, did someone really paraphrase an original document? And this approach would say, no, both of those documents are different. Well, they are not different. Semantically, they are the same, just syntactically or using the words, they're different. So there are other deep learning techniques that could do things at a semantic level as well, and say that, these documents, despite having different words, are semantically very similar to each other. Yeah.
Thank you.
Okay. Now, so this was just one of the 2 examples that I had. I'll show you the second one now. Okay, so that was text documents. I have image, the same exercise, but this time for images as well. So in this slide, you see a number of images. So the source image is over here on the left, and there are a number of derivatives of the source image. So you can see this image is tilted to the side. This is the same image, but the size has been changed and the texture has been changed. Over here, we've put a filter, a sunburst filter on the source image, and this has changed the colors. It's the same image, but the colors are now different. So can we still find out if all of these images are derivatives of the source image? And that's another technique that we'll be trying. This time we'll be using image classification techniques for this. The technique that I'll be showcasing is called Sift Scale Invariant Feature Transform. It's an approach that is used in computer vision. And what Sift does is it locates features. Features are key points in an image. So it finds out features. So for example, if there's a feature and there's a sharp point somewhere, so it would locate that and say that, oh, you know what, this is a feature of in that image. And key points are scale and rotation invariant. That's why the word invariant comes over here, scale invariant, meaning that if we have two images, one is and they're identical, but one image is small and the other image is large, it would detect the features in both the images and it would ignore how the distance between two features. So the scale is irrelevant in Sift. Sift just focuses on the image, on the key points, the features, and it ignores the placement of those features. So that's why key points are not affected by the size and orientation of the image. So there are multiple steps involved as well. So the first step is, looking at the image and trying to construct a scale space to make sure that all of the features are scale independent. And I'll go through this exercise as well. Then step 2 is identifying all of the suitable features which are present. So for example, when we ran the algorithm across on this image, it found a number of points that it found, which it thought it was interesting. So this is the shadow of the bridge. So it found those points, and then obviously the bridge as well, and the grass and the waves and stuff like that, probably something birds over here. So it found a few interesting points, a few interesting features in this image. And this is what the algorithm is going to remember. It won't remember the image, but it will remember the key points. And we can do this against another image as well. So this is the second image, which has been rotated by 90 degrees. And we can see that despite the rotation, it still found a number of images which are very similar to the ones from the previous image. Not identical. Yes, it did miss a few of them. Like you didn't see the images over here, and you don't see some of the images in the shadow under the bridge. But it did find a number of features which are similar to what was found in the previous step. These key points have descriptors which are associated with each one of these points. What are descriptors? Descriptors are essentially some information that define each key point. So what is the direction of the feature? Is there a certain alignment to it? So is there a certain gradient to it? So all of these things are captured. This is each key point has a unique fingerprint that is captured and maintained. And that is how we are able to compare the key points and the key point descriptors. Okay, let's take a look at this. So I have a Jupyter notebook over here, and I'll go you through the code that is going to be present. A Jupyter notebook, by the way, it's a notebook is where we write Python code, and Jupyter is a technique. A Jupyter notebook is an approach for writing Python code and running it against a server or a kernel without having to write like a Python script and then running it outside. It's very nice for, it also contains a lot of documentation or inbuilt documentation. Like you can see, I've put in a lot of inbuilt documentation as well. So this makes it very easy to exchange knowledge with another person, because if you put it together, Jupyter notebook, and you run it over here, it's very easy to follow and see how things are coming along. So I'm running this Jupyter notebook is housed on a location called Google Colab. So it allows us to come up with Jupyter notebooks and share it with other people if required. Okay, so let me run this right now. And I need to do first some housekeeping first, so I'll do that. I need to uninstall certain libraries and install older versions of them, just because I'm using some functions which are not present in the newer version, at least don't work in the newer version as well. I'm importing certain libraries that I need. So remember those images that I showed in the slides? Those images are all present over here. So I'm going to be downloading them one by one and showing them to you. So this is my original image. This is a duplicate of the original. This is the rotated version. This is the one with the size and color changed. This is the one with the filter. And this is the one with the texture, the old texture that, normally images that had 50s and 60s. Okay. So I have now my data. So the first step was getting all of this data. I downloaded it. Now I have it in my notebook. I am now going to compare to see if images are identical or not. Identical is a very simple method, way. Just compare two images, just do a subtract between the first image and the second image. And if nothing results, then the images are identical. There's nothing complicated about it. What we're doing is we're going pixel by pixel and checking and doing a subtraction between two pixels. From the source image and the destination image. And if both of them are identical, meaning they're the same color, then we'll get a black color for that pixel. And if you do that throughout the image, then you'll get a solid black screen. And that means that two images are identical to each other. So that was the first step. But the second step is where the interesting stuff happens. So if two images are not identical, but are similar, not identical, how do we determine this? So that is the Sift algorithm that we'll be using that I introduced in the slides. So first I need to create a Sift object. And then once I have that, I'm going to take images. So in this case, I've taken three images, the original image, the mixed color image, and the rotated image. And you can see the dimensions of the image are different from each other. So I'll calculate the key point and I'll calculate the descriptors for all of these images right now. So it does that. This function does it in a very simple step. So all of the complicated mathematical stuff is hidden from us, thankfully. And all we're doing is just calling those functions and we're getting the image. Okay, let's take a look at what was calculated. What was the key points? Image. Okay, so this was the original image, and you can see the key points indicated over there. So in my slide, I already had this picture that you saw, and we can do this for the rotated as well. Yeah, you can see that for the rotated as well. So it did detect a number of key points. Okay. Now, now we have the key points and the descriptors. We need to compare them. So remember in the text classification or the text similarity analysis, you used a technique called cosine similarity to determine the similarity between two vectors. Well, over here, we'll be using another method that is geared towards image descriptor similarity indicator. It's called Flam-Based Matcher. And again, I won't go through the maths right now, but the idea is we give it both the descriptors, the two set of descriptors between the images. So we have that, and it's going to calculate how similar they are using the KNN matching technique. There are multiple techniques, and we'll be using the KNN. KNN stands for K means nearest neighbor matching algorithm. And so again, it's all that complicated mathematical stuff is just written in one line. Once we have that, now we can run this and see. Okay, so here's the thing. Let me tell you what happened over here. So I have set a threshold. Over here, my threshold is 0.8, which is a fairly high threshold. And what I'm trying to say is that for all of those matches between the two descriptors that were provided, find the number of good matches that exist. If this number that is above the threshold is fairly high, so I'm just trying to get the number and I get it 190 over here. If it's fairly high, that means two images are remarkably similar to each other. So my threshold is quite high, and I can change this. I can put it to 0.5. If that's the case, then I'll get um, a different set of numbers. So based on the threshold that I have, so if I keep a very low threshold, meaning the number is going to be low. This is inversely. So the lower the threshold, the more similar the images are going to be. So if I, despite a low threshold, if I still get a number of descriptors which are common across two files, that means that indeed these two files are similar to each other. Not identical, but similar to each other. And this is what I'll be doing. So I'll be going through multiple files. I'll take a source file and I'll go through all of the other images. And based on this threshold value, I'll try to see which two images are very similar to each other. And based on that, I'll say that, you know what? I believe that this image and this image are derivatives of each other. That it is. That's how it's happening. And what this does is, this is going to show, so you can see this. So just to give an example of the matching of key points. So this is my source image, and this is another image. So remember, we detected key points in both the images. You can see these lines as they're being traced. This is how it's matching key points from one file to another file. So it's saying that, okay, you know what, this key point is very similar to this key point over here. And this key point is very similar to this key point over here. So you can see that it is indicating which key points are matching against each other. And I just have 23 points right now. So it's doing that for 23. But if I had a different threshold and I got a greater number of points, then it would show more lines as if they're going from one image to another image. But through this method, we can say that, yes, indeed, two images are very similar to each other, or not very similar to each other, and detect all of the derivatives which are going out, which are floating around in an organization. Okay, so to conclude, one could easily, so this is just a prototype, this is just a demonstration of different techniques that can be used for finding derivatives based on the data source, the data type. But one could productize this. So this is, for example, a solution that is shown, where we could have Apache Spark that is going through, we have agent applications over here that are sending vectors of data to a production system, an enterprise application that is presumably built over Apache Spark. And then we have things like Apache Kafka, which is doing real-time incoming stream ingestion. And the machine learning code in Apache Spark is running and processing it all in real time and generating results. And someone can visualize those results using a BI tool. But this is one way of productizing what I've shown right now. Yeah, and that's it. So the agent applications could be running on laptops, PCs, and other places. And all they're doing is just taking all of this unstructured document, converting it into numeric form and sending to a central server, which is going to be then processing all of this information together. So yeah, to conclude, derivative data is a huge problem for organizations right now, especially organizations which need to be compliant to various regulations. And organizations can leverage the power of AI to find all of the derivatives which are floating around in the organization and highlight them so that someone can go and delete all of that data if it requires to be deleted. That's it from my side. Thank you, everyone. Thank you for this. This is my LinkedIn Pro information, my Twitter information. Please connect with me on LinkedIn and Twitter if you have any questions on this topic or any other topic that you feel we could have a conversation on.
Yeah. Zia, are you okay to open the floor for the questions?
Yeah, I'm good for that.
Yeah, go ahead, guys. If you have got questions, you can ask them here, or if you would like to type them in the chat window, you can type in there, and Zia should be able to answer them.
Yeah, I have a question. This is Raham. So how does your solution differs or maybe or enhance the current DLP solutions that are available in the market that are offering similar, solutions, similar technology?
Yeah, so there are a number of solutions out there that do fairly similar things. This is a special use case that I was intrigued about. So I like to tackle problems that
Hmm.
are at a nexus of two or three different spaces. So, for example, this is at the nexus of data security, machine learning, and IoT, right? So all of them are coming together. And I thought, let's do a cool project around that. So it's just an experiment, a weekend thing that I did.
Hmm.
Nothing really geared towards a solution that was to come out of it. But there are organizations that use these techniques to solve other problems. For example, YouTube has a plagiarism monitoring solution or something that a copyright violation solution. So let's say if I upload or someone uploads a video that was originally produced by someone else, an organization, a media company, or some other YouTuber, and if someone uploads it, then YouTube will flag that as copyright violation because it has determined that portions of that video, if not the entire video, is a copy of a media company's video. So that's
Hmm.
how it brings down videos because of copyright violation. So that's one way where it does similarity analysis to determine if two documents, video files in this case, are similar to each other or not. Plagiarism check is also done in a similar manner. So if in an academic environment, if someone submits an assignment, and it often goes through the plagiarism check to see whether this submitted assignment is similar to the hundreds of thousands of other submitted assignments. And if so, then that would be flagged as well. That also works in a very similar manner where it's doing text classification or text analysis and trying to see the outcome of that document if it's similar to another document that is already in its databases, in that platform's database. So there are these approaches can be used to solve different business problems. I chose one that was peculiar to data security and data governance.
Yeah, no, this is something that I've been working with my clients, specifically clients in software development. In that. And obviously, when you're in software development, your source code is your asset,
Yeah.
and you need to protect that source code from leaking, whether through developers' workstation or through any other means. So the current solutions that are in the market, they are very limited when it comes to protection of source code because there are multiple technologies out there. There are changing technologies out there. There's Java, C Sharp, C++, you know, and every day there's a new language, new framework. So do you see, artificial intelligence, helping in that area where it can identify code for specific technology and then help prevent leakage of that?
Yes, this is, I believe, actively being used right now, where there are ways of determining if a code has been derived from another code base. The
Okay.
problem often comes is, and see, organizations don't open up their source code for review. That's why it's difficult to find if someone has copied the code. That's
Sure.
difficult to find that. In public repositories, then it might be a little more easy. For example, if someone is uploading GitHub a code to GitHub and it's available publicly, then over there checks could be done. But in
Mhm.
private code bases, it's difficult to do. However, I know there are organizations, what they do is, so for example, if an organization is going through an exercise where someone else is acquiring and the acquiring company wants to make sure that no code was stolen in the formation of this product, the
Mhm.
acquiring company may want to do their due diligence. And code
Right.
scanning is one of the activities that they'll do to make sure that whatever intellectual property they're acquiring has been properly managed. So this is an exercise that I've seen organizations do. Yes.
Mhm. All right. Thank you very much.
Yeah.
Yeah, we have got another question from another participant. Would you like to read, or you want me
Yeah.
to read it
I'll
for you?
read the question. So, do you have an AWS native services, Marcy, SageMaker playing a part into address this use case? No, I don't have a lot of exposure to AWS native services. I know that they can be used. I generally do things directly on Python and using Python libraries, and not use that many vendor-specific technology. So, but it's very easy to convert this to run on something like, for example, on Amazon, AWS using their services. but the normal libraries that are available on directly accessible from Python, TensorFlow, scikit-learn, NLTK, if you're using computer vision, then OpenCV, these are fairly good.
Excellent. Guys, any other questions?
Well,
Hazy, it's Dennis. Oh, go ahead. Sorry, go ahead, Ralph.
I'm new to this whole process. Very much, really great listening to you. But is it proper to ask a question off topic?
I think anything goes.
Oh, thank you. But I have a really serious problem in that I need to be able to extract, say, from a Word document, the metadata, attributes, and text all as a text file.
Yes, so that is possible. There is a ability to extract metadata. In fact, the code that I have, if I could show it to you. What I did over here is I extracted metadata for that file, and I was capturing a lot of that information. So for example, the file name, the file type, CRC values, and I was capturing size. So I did extract a lot of information, and depending on the programming language you're using, that metadata is all accessible. All you need to know is find which function to use in order to get that data. And you can have that information. Like for example, in Python, there's a library called file type. If given a file, you can extract different kinds of metadata about that file.
Okay, thank you.
Yeah.
Zia, did you say, is there a commercial application of an agent? Like, are there any agents that are in use today, or is this still sort of an area of research? You mentioned the YouTube, has an algorithm to detect copyrighted content within a video. Are there any other agents that are in production today, or is this still more or less active research?
No, there are commercial applications out there. So this YouTube, I mentioned YouTube. I believe Plagiarism is another check. I believe there's a company called Security AI that does something similar where they try to find copies of data that exist in an organization. So there are these kind of agent applications, commercial companies that do this kind of work. So this was just an experiment on my side, a prototype on my side, but I know there are companies out there that are using these techniques and commercializing them, and of course gaining considerable revenue. Those solutions are far complicated, far more robust, much better developed because they have to deal with all kind of contingencies and eventualities, but they are out there.
Okay, thanks.
Sure.
The floor is still open. You can ask the question if you have. What I have done is I have shared my LinkedIn profile as well in the chat window. So you guys are welcome to connect with me, or if you would like to share your own personal profile, please do so in the chat window as well. The purpose of these type of talks is basically to build and grow up our community so that we can share the ideas, share our knowledge, and we can help each other to progress and to help each other to build your own career and your professional capabilities. So go ahead, Dennis. Do you have something else?
No, I'm just nope. No, I'm good, thanks.
Well, since there's not a particular lineup of questions, Zia, let me get back to that original question, if I may. Is there a standard program that I could run to take all Word documents coming to me to automatically do the process of metadata, attribute, and text? conversion into a text-based file?
Yes, it can be done. You could have an application, or you could have a cron job, or some kind of job that wakes up every few seconds, every few minutes, or once an hour, which goes and reviews the files in a location, goes and opens them, extracts the metadata, and stores it somewhere else. So that is entirely possible to do.
Okay, so it'd have to be C++ or Python code written app that actually does that. So it'd have to be a file.
Yeah, yeah, yeah.
Oh.
You may find something out there, but again, it's a matter of looking and seeing if someone has done that and uploaded it for other people to use.
Then what would I call that?
I would say just search for Google. It's difficult to see what kind of search term to use, but just say tool to, I don't know, extract metadata from file.
Sure.
And, yeah, and maybe something like that would come. But you're right about the metadata or even file attributes. So instead of metadata, just say, file attributes to see if something like that comes up.
Thank you. You can use, there is a tool available out there. I can talk about video and audio and some documents. It's called EXIF tool, EXIFTOOL.
Rehan, would you mind writing that in the chat window so Rolf can copy it? It will be easier for him.
Yes, I can do that.
If someone else can add any information into the chat window, that would be good.
Rehan, thank you. I'll buy you a.
Yeah, I'm a photographer, so I use that tool quite often to actually understand what kind of lenses that I'm using the most, what kind of cameras that I'm using the most in my photography journey over the course of time. So that gives me a good idea to sell the lenses that I'm not using and to keep the lenses that I've been using quite a bit.
Are you familiar with photography lensing?
Yes, I do a lot of photography. What kind of questions you have?
Oh, it's a complex, long question.
All right.
I've got your contact info. I'll go bug you another time if you don't mind.
No, that's perfectly fine. Anytime.
Anybody familiar with display technology for rapid on-off times for complete total 4K type picturing? Okay.
The silence is deafening.
Yes. Sorry. Hey, thanks, guys. You have no idea. I've been working on a project now for 4 years, and this is the first time I've actually spoken to somebody and received a smidgen of help. Thank you. Thank you.
Here you go.
All of you.
This is the whole point, Rolf. This is the whole point of making things happen like this so that we can connect with each other and we can share the ideas. I think I'm glad that it's working.
Well, hopefully all of you will remember me at some time in the next 2 years, because I have discovered a new class of computer components such that when an information file is presented, like a Word document, I've actually done this, have presented a Word document to the input of this new class of computer components. The output was the save file, no longer infected. And I've done this in my lab, and I've got a bank president who has offered to fund my commercial product development for a small equity stake. All I have to do is build a basic proof of concept to demonstrate the technology. My background is 30 years in electronic components. I understand what components do, but I just don't know how to make them work. And this has been my problem in building a proof of concept. Plus the fact, when I tell people I can build malware secure computers that don't need detection software, people look at me as if I've got a 3-headed horse for a brain. So,
Yeah,
but-
you want to look at a operating system called Cubes OS.
sorry?
You want to look at an OS operating system. It's called Cubes OS. It's virtually the most secure operating system out there, and it cannot be infected by malwares or other malicious.
I would suggest, Rehan, go ahead and type it again. I think it will be
Yeah,
better.
yeah, I'll do that.
Thank you.
Actually, I've actually proven the basic concept using Red Hat Linux. I've actually processed my malware and fed. Basically, it's two computers. There's the input computer, which was malware infected. It went through the new class of computer components, and then it resided in computer, physically isolated as a no longer infected file. I've actually done this.
Yes, so that is something that you can do. Yeah, Cubes OS, it's a Linux-based operating system, and it uses virtualization technology to isolate various processes from each other.
Okay. Excellent, excellent, excellent.
Okay, guys, I would have to drop off. I have a 7:30 hard stop. So if there are any questions that I could help out with, please do let me know. You have my contact information. You know, this is an area, data security, cloud security, machine learning is an area of interest for me. So it'll be good to have those conversations with everyone as well.
Right.
Yeah, thank you very much.
Thank you, Zia.
May I ask one more question, gentlemen? Does anybody know of where I could working on trying to build a proof of concept demonstration computer with my limited knowledge? And what I need to do is go to a certain point, and then I run into a wall. I was hoping to be able to find a hardware design consultant that pick up the phone and pay them $100 or $200 for a half hour or an hour's time to be able to guide me into resolving that particular problem, so that I may stumble further along in my proof of concept design until I reach the next problem. Any suggestions on that?
I am not the hardware guy. So I don't know many people in the hardware space.
Yeah. Gentlemen, thank you, thank you, thank you, thank you, thank you, thank you.
You're welcome. Ross, let's connect over the LinkedIn. I'm sure that you should be able to connect with me over the LinkedIn. I'm sure I should be able to guide you into some direction which can help you in finding either some help or someone who can help you into the specific direction that you're looking for.
That would be awesome. Absolutely awesome. Thank you.
Welcome. Zia, thanks very much once again from myself, Janet, and on behalf of IEEE Toronto Computer Chapter. And guys, everybody else, thank you very much for attending and for your input, your questions. I'm glad that you guys had spared some time with us. And I'm sure I just would like to emphasize one more time that 2021 is the year that will be focusing more towards the security in the cloud, any angle that we can discuss in the future, how we can basically perimeter the security fence around our data, around our application, or anything else in the cloud or on-prem. And we'll continue this journey, hopefully, in our couple of upcoming sessions as well.
Thanks, Eunice. Yeah, good job.
Thanks, Eunice.
Thanks, Zia.
Thank you.
Thank
Take
you,
care,
guys.
guys.
Thank you, everyone.
Bye now.
Thank you.
Bye,
Have a
guys.
great one. Bye.
Bye.
Bye, guys.